Hello, Assalamu alaikum. This is Mr. Junaid, and today we're going to discuss about the Coulomb's law. So before that, we will just do some basics. So in the first, we will just discuss about the electrostatics, like what is the definition that we have for the electrostatic. So the electrostatic is just the study of the electric charges at rest, which are under the action of the electric forces. So we call this as the electrostatics. The next thing that we have is the electric force, so we will write that one as well. So now we have the electric force. So the electric force is the force which holds the positive and the negative charges that make up the molecules or the atom. So we'll write the definition for this one as well. Okay, so now we have two definitions. The first one is the electrostatics, which is just the study of the charges at rest. The next one is the electric force that holds the positive and the negative charges. So as we know that the human body is composed entirely of atoms and molecules, so we have our existence just because of this electric force. So we will discuss the Coulomb's law, like what we have in this law and what we have to discuss. We'll go on to that. So as we know, like we have two kind of charges. The first one we have is the positive charge, the other one we have is the negative charge. So we have only two kind of charges. Okay, so we have two kind of charges, the positive charge and the negative charge. So we know one thing, that we use the negative charge for the electron, and we also know that we use the positive charge for the proton. And the next rule we know from our previous knowledge is that like the charges which are alike, they repel each other, and the unlike charges, they attract each other. So here we have the like charges, that means the positive and a positive charge, they will repel, and a negative charge, they will repel as well. And for the unlike charges, that means we have a positive charge and a negative charge, so they are the unlike charges and they will gonna attract each other. So now we will discuss, like we have that force, that electric force, which holds the positive and the negative charges. And what we are finding next, that we have a force of repulsion and attraction, and that repulsion force is for the like charges and that attraction force is for the unlike charges. So we will investigate about this force, like what are the factors that we have for this force. So to investigate the quantitative nature of this force, so this force was firstly measured by the French engineer Coulomb, and he has given us a statement, or he deduced a statement, and he named this as a Coulomb's law. So according to this Coulomb's law, it states that the force between 2 point charges is directly proportional to the product of the magnitudes of charges and inversely proportional to the square of the distance between them. So we have two things in this statement. The first statement says that we have the magnitude of the force is proportional to the magnitude of the product of the charges, and secondly, it is inversely proportional to the square of the distance between them. So now we have two parts, so we'll convert these two equations into a single mathematical expression. So if we convert these two equations into a single mathematical expression, we have a constant k, which is the constant of proportionality. So the value of this constant depends upon the two factors. The first one is the nature of the medium that we are using between these 2 point charges, and the second is the system of units in which the force, charge, and the distance is being measured. So the nature of the medium that we are using here is the free space, and the system of unit that we are using here are the SI units. Then in this case the value of K equals this, and in this 4 and the pi, these two are the constant values. Epsilon naught, it is the permittivity of the space known as the electrical constant as well. So the value of this permittivity of free space epsilon naught equals 8.85 into 10 raised to the power minus 12. So after putting all these values in this expression, the final value that we have for the K equals this, and if you place this in the Coulomb's expression for the force, for the magnitude of the force, so we have these two equations. So we can use both of these two equations, and these two are the equation for the Coulomb's force in the free space.